All right, today we finish up our unit. I feel like we just started it, because we did, right? Today we're solving absolute value inequalities. So we studied absolute value equations, we figured out how to graph these functions. So kind of the last piece when it comes to absolute value is studying how to solve the algebraic way when it comes to inequalities. And inequalities, if we remember, right, we're going to have less than and greater than, and then we got the equal to's as well. So those are the inequalities that we're going to see today. We're going to end up with a solution set, and because our question is asked with these inequalities, I'm going to give the answer in inequality notation. If you like other notations, right, set notation, interval notation, you can use those. In fact, when we do kind of one of the riddles for practice, they are using some of those notations. You're free to. Just know that on a lot of my answer keys and stuff like that, since we started with inequalities, I'm going to give the answer in inequalities, and then we'll have to graph it on a number line. So we're kind of going to remember some things that we probably did in Algebra 1 and combine them with some new things here in Algebra 2. So I kind of wanted us to think about how to solve inequalities visually. So if you're more of a visual person, maybe this will make a little bit more sense. So what I have here is I have this absolute value function graph, right? My vertex is at -3, 1. My slope is 0. So that is how I ended up with this absolute value equation here. The other thing that I have graphed here is just 4. And when I say 4, I mean the line y equal 4. So basically, I have y is equal to this whole thing, and y is equal to this whole thing, and I graph them both on my coordinate plane here. That's what this line here represents. Just as a reminder, I know horizontal lines and stuff like that we haven't looked at in a while. So now looking at this absolute value function, I want to know for what intervals is the absolute value function greater than 4? And when I ask for these solutions, I want for what x values is this true? So when I look at my function, I say, okay, here's my line, y equals 4. When is the absolute value function above it? Well, it's right here, would we all agree, right, for this going on and on forever, and also over here, going on and on forever. So how do I figure out what those solutions are? I come down here and I look at the x values where that happens. So it happens when x is less than 6, or -6, excuse me, or when x is greater than 0. Think about that for a second, and just make sure that this answer makes sense to you. Please, please, please ask me if there are questions. Right? Because we just got done with a whole section on notation, right, where I would probably write this answer over here as like from -infinity up to 6. And I would have written this solution over here, right, as 0 to +infinity. These are still correct answers. But as I go through and solve the equations, I'm going to get stuff that looks like this. So if you do want to translate it from this inequality notation to interval notation, you can.
Is that supposed to be -infinity to -6?
Oh, sorry, thank you, -6. Thank you. Yep.
Is the -6 and 0 not included?
Not included. The reason being, right here, it looks like that's where they cross over. So that's where they're equal to. And notice I started with a greater than. If this said greater than or equal to, then yes, I would have to include them. So just kind of, and making that connection, asking these questions, like that's what I'm hoping for. Because when in doubt, if you're struggling with the algebraic process, you can always look at these graphically on a calculator as well. That might help to kind of jog the memory and the idea. All right, let's look at the next example because I don't have anything graphed right here. So we've got to do it all. We're going to do it together. The first thing is I'm going to just look at the equation here. I'm going to worry about the one later, and I want to graph this absolute value equation. So just looking at this, we've got this function. What, does this open up or open down?
Up.
Opens up. What's my slope?
1.
Yep. And then what's my vertex?
2, -3.
So let's go ahead and graph that. 2, -3. And then my slope is 1. Graph as many points as I can here. Connect the dots. So there's my absolute value equation there. The next thing I'm going to graph is this part here, which is just going to be the equation y is equal to 1. So now that we've had practice in the first example, we know y equal to 1 is just going to be a horizontal line. So I'm going to go ahead and graph that as well. Now I'm going to come back to my function and say, okay, when is the absolute value function less than or equal to 1?
-2 to 6.
Exactly. Remember, I'm going to look here and say, okay, I only care about the x values. So I'm just going to kind of bring my cursor down and say it goes from -2 to 6. And we know if we're using inequality notation, we're going to write it like this. I write the smaller number first. Because this is less than or equal to, I need to actually consider these points right here. They are on my solution set, so I have to put equal to's here as well. If I wanted to write this in interval notation, it would look like that. Okay? So now that we've done the visual or graphical representation, let's get to the algebraic method for figuring this out. So we've got some functions here, and yes, I threw in some letters, as math teachers are always want to do. So I have the absolute value of ax minus b is greater than c, and then I have the absolute value of ax minus b is less than c. So just as a reminder about our different inequalities, remember less than kind of makes that, right, L shape is what we look for with less than. And if we have a less than statement, so say we have this statement here, how am I going to solve this? Well, I'm going to write one equation. And I'm going to go from -c to +c. Hopefully this will make sense as we actually start solving these. So notice I kind of took what was in the absolute value bars and I put it in between my less than statement here. And this is what's called an AND statement. It is a compound inequality. I have some stuff in the middle, and then I have my start point and my end point on either side of less than. So no, I didn't spell this wrong. It's an AND statement. If you have a less than statement, you're going to write a compound inequality. One big inequality like this. Where if it's greater than, let's remind ourselves what greater than looks like. Those are the symbols that we use for greater than. I'm going to write two statements, so I'm going to end up with an OR statement. The first one, we just copy down exactly as this looks without the absolute value bars. So I get ax minus b is greater than c. And here's the tricky part. The OR statement is I again take what's in the absolute value bars, but the other option is that it will be less than negative c. So that's just kind of an overarching view of how we're going to algebraically solve these. We're going to start with the less than inequalities first. They tend to be ones that students like the most. So let's look at some examples. And you'll notice with all these, we do have number lines where we've got to put in our solution sets once we're done. Whenever you're solving these, it's going to follow the same process that we've seen before. We're going to want to isolate the absolute value. So before you go ahead and set up your statement or statements, depending on if it's less than or greater than, you want to make sure the absolute value is all by itself. You got to get everything around it on its own. You also will want to check for trick questions. On your homework, you may see a trick question or so. Remember that when we're talking about absolute value, it always ends up being positive. And what I mean by trick questions is this. Let's look at our first example. The absolute value of x plus 2 is less than 6. What if this was a negative 6?
That would be false.
There's no way, right, that the left-hand side, its absolute value, could ever be less than a negative 6. If you come across something like that, what would my answer be?
No solution.
No solution. So just always have that kind of in the back of your mind as you're solving some of these. Oh no, my flip chart's just died. Let's see if we can get it back up. Hopefully I won't have to restart. Did it quit unexpectedly? All right, let's see if it actually works here. All right, let's see if I need to calibrate. All right, so let's actually start solving these. I have a less than statement, which means I'm going to set up one compound inequality. I'm going to remove the absolute value bars, and I'm going to go from negative 6 to positive 6. So now how do we solve this? Well, what I want is just an x in the middle. I don't want anything else with it. So how do I get rid of the plus 2? I subtract it, right? I follow the same kind of principles that we've studied when we talk about algebra. The thing is, when I subtract 2, I've got to subtract it everywhere, right? Now that we have a compound inequality, I have to do it in 3 locations rather than just 2. So I get negative 8 less than x less than 4. So that means x is going to be greater than negative 8 and less than 4.
So if we were to have to write the or equal, like the line under the less than, would it first have to say x, or the absolute value of x plus 2 is less than or equal to 6?
Yes, it would start from the beginning, from the very original equation. Yep. So now I want to graph this on my number line. I'm not looking for anything fancy. I've got negative 8 here. I've got 4 here. Since x can be any number in between negative 8 and 4, but not including those, do I use an open or closed circle?
Open.
Open. So I've got an open circle at negative 8, an open circle at 4, and then however you want to shade it in between. All right, let's look at our next example. Is it isolated, the absolute value?
No.
Nope. So first thing, before I even set up this compound equation, I've got to add 2 to both sides. So I get the absolute value of 2x plus 1 is less than 9. Once I have this, I can set up my compound inequality. I'm going to go from negative 9 up to positive 9. And yes, I have all that 2x plus 1 in there.
Will there ever be a time where you have less than or equal to?
Yes, if they start with a less than or equal to.
Oh, okay.
Yep. So you just follow what the original question says. You write your next statements based on that. So from here, I solve it the same way I would an equation. I subtract 1 from both sides. Sorry, I'm running out of space. So I get negative 10 less than 2x less than 8. And then I divide by 2. And I have to divide everything by 2. So that means I wind up with x is greater than negative 5 and less than 4. I go ahead and graph this on my number line. And because it is less than and not less than or equal to, I'm going to have open circles, shade everything in between. Questions? Looking okay? All right, let's look at the next example, because of course I threw a wrench in this one. Something we'll have to remember about inequalities, which it may have been a while. First things first, I do have a less than or equal to, so now we'll be able to have some closed-in circles once we solve it. It is already isolated, so I can go right to the next step of setting up my compound inequality. I'm going to go negative 4 less than or equal to 7 minus x less than or equal to positive 4. Now, normally in algebra, when we're solving for x, I can move whatever I want around, right? If I wanted to make this a positive x, I could just add x. Well, unfortunately, when we have compound inequalities, that x has to stay in the middle. So I can't move it around. Yep.
Would you divide by negative 1?
Not yet. I first have to get rid of the 7.
Oh, yeah.
Right? Reverse order of operations. I'm going to look to add or subtract something first. Since it's a positive 7, I need to subtract 7 from both sides. Now, Kevin, you're right. I do need to divide this by negative 1, so I wind up with a positive x. I'm just going to rewrite it down here. Because something funky happens. When we talk about inequalities, when you divide or multiply by a negative number, yep, I got to flip it, right? I've got to flip my sign completely. I keep the equal to part, but I have to flip my sign. It makes me cringe to write this up on the board. You probably, or hopefully you see why. When we write intervals, whatever notation we're using, do I put the small number or the big number first? I gotta put the small number first. So this is why this is driving me crazy. What this says, right, just look at it individually. This is saying that x is less than or equal to 11 and x is greater than or equal to 3. The normal way that I would write this is the other way around. Right? If this was an ACT problem, they're going to write it in this fashion because when we write compound inequalities, we always put the small number first and then the larger number second. Now we must graph this. I've got my 11. Notice it's now a closed-in circle, my 3, and I shade everything in between. Go ahead and try letter D on your own. No tricks on that one. Just a normal equation. Anybody notice anything about this example? It's pretty similar to the one right above it. So the first thing I have to do is isolate my absolute value. So before I even set up my compound inequality, I've got to divide by 3. Then I can go ahead and set up my compound inequality. Subtract 1, divide by 2. I get that x is greater than or equal to -5 and less than or equal to 4. And then I've got my answer here, closed circles, everything shaded in between. So that is how you algebraically solve the less thans. Let's move on and look at the greater than on the next page. You guys having a stare off back there?
No, please just copy me when we do anything.
All right, so when we talk about greater than inequalities, so say I have the absolute value of x is greater than some number. When you see that, you have to break it out into 2 separate inequalities. The first is that x is greater than the number. All you have to do is remove the absolute value bars. The trickier one is you have to change it to a less than and then change your number to a negative number. Same thing, right? You're going to need to look and make sure your absolute value is isolated, and you'll have to check for trick questions. Let's say I wound up, solving it or whatever, or I see an original equation, something like this. So say I had the absolute value of x is greater than -8. When does that happen? Well, what if I plug in -10? What's the absolute value of -10? 10. Is 10 greater than -8?
Yeah.
So this is going to happen, right? This is always going to be a positive number. Is a positive number always greater than -8?
Yeah.
So in this case, my solution would be all real numbers. Or, right, -infinity up to +infinity if you wanted to write it that way. So that's the type of trick question you will see if we're talking about greater than numbers. So we still have that process, right? Isolate the absolute value and double check for trick questions.
Is that a symbol for all real numbers like an R with the
Yep,
same
that's exactly right.
Okay.
I love that we're thinking about notation, yep. So as we go through and solve these, just holler if you see a trick question. I don't think there's one on my notes, let me double check, but I do think you'll see one on your homework. I can't remember which one it is, less than or greater than, but just be mindful of that as you go through and solve these. All right, so for example 4a, the first thing I have to do, right, is isolate my absolute value. So I'm going to divide both sides by 2. So I get the absolute value of 3x minus 7 is greater than or equal to 5. And this one ends up being a little bit more work because you've got to set up these 2 separate inequalities and solve them kind of separately of themselves. So my first one is 3x minus 7 is greater than or equal to 5. I write it just as it's written right now. And then my other inequality is going to be 3x minus 7 is less than or equal to negative 5. Right? We flip the sign and we change the number to be negative. And then I just solve them independently of each other. So I'm going to add 7. I get 3x is greater than or equal to 12. Divide by 3. X is greater than or equal to 4. Over here, I do the same thing. Add 7. I get 3x is less than or equal to 2. Divide by 3. I get x is less than or equal to 2/3. So your answer is both of these things here with the word or in between. I know I could have written that a little bit prettier, but that is what your answer is. So let's go ahead and graph this to the best of our abilities, right, on my made up number line here. 1, 3, 4. And let's just say 2/3, right? I broke this into little tick marks in 1. So I've got 2/3. I'm going to fill in a whole circle because it's equal to, and since it's less than, I'm going to shade everything down here. And then greater than or equal to 4, same thing. I'm going to do a filled in circle, a closed dot, and then shade everything on the edges. When you have or statements, that's when you're going to be shading in the number lines, the arrowheads of the number lines. When you have an and statement, that's when you're shading in stuff in between. Questions on that? Kind of a tricky one to start off with. Let's look at letter B. The absolute value is already isolated, so I can jump right to step 2, which is setting up my 2 inequalities. I have x plus 4 is greater than or equal to 6, or x plus 4 is less than or equal to negative 6. The only thing I really have to get rid of here, right, is my 4. So I'm going to subtract 4. And I get that x is greater than or equal to 2, or x is less than or equal to negative 10. I've got my 2 and my 10, so x is greater than or equal to 2, closed in circle, shade up here, negative 10, closed in circle, shade down there. Questions on that? All right, we've got a couple more examples to do just to make sure we feel confident here. My absolute value is already nice and isolated on this. I'm just going to double check there's no trick questions here. No, I don't see a trick question on either of these. So we can just go ahead and set up our 2 inequalities. We have 4x plus 5 is greater than 13, or 4x plus 5 is less than negative 13. Notice I didn't start with an equal to, so I don't have an equal to in my inequalities when I set those up. 5. I get x is greater than 2. I get x is less than negative 9/2. Yep, I'm going to simplify my fraction as I go. So I get x is greater than 2, or x is less than negative 9.9/2. Excuse me. And now I must go ahead and plot these. So negative 9/2 is negative 4.5, so somewhere in between negative 4 and negative 5. And I have an open circle for both of these, right? No equal to's there. Go ahead and shade. Shade. Just chugging along, looks good, no questions. Let's do our last one. 2x plus 7 greater than 1, or 2x plus 7 less than negative 1. Same process. Get the x all by itself. So on this one, I get x is greater than negative 3 or x is less than negative 4. Doing okay on these? Not too bad, right? So this is what I mean by you're going to end up with solutions, right, that are not written in set notation or interval notation. You will just have inequalities as solutions, but you do have the option, if you want to always write these with different notations. I would not take off for that if that's something that you're comfortable with. Let's finish up our notes with some word problems. So these word problems are, again, right, out of our textbook, a little bit formulaic. I guess the nice thing about these word problems is they're extremely formulaic. Because I want you to just read this and come up with the solution. We're going to write this as an absolute value inequality, but I have a feeling you guys can kind of figure out what the answers are before we even do that. So a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounces, right? You got to make sure when you open that box of cereal, you better have enough cereal in there that you're not sending it back. So write and solve an absolute value inequality to find the range of acceptable weights. So it's supposed to weigh 13.8, but it can vary by as much as 0.1 ounces. So what is the range of acceptable cereal weights? 13.7 to 13.9, right? So your answer is going to be from 13.7 to 13.9, right? And it's as much as, so we have to also have an equal to in there. So how do we write these as an absolute value inequality? Here's how you do it. It follows the same process. So you first have your absolute value and then x. You subtract whatever is the perfect amount, right? That is the perfectly weighted cereal box. You end your absolute value. And because, right, my range is a less than answer, the difference from 13.8 has to be less than or equal whatever your threshold is. 0.1. Now let's solve this and make sure we get out the answer that we already figured out. So since this is a less than statement, right, I remove my absolute value bars and I just write one big compound inequality. So I go from negative 0.1 to 0.1. And then in order to solve this for x, I add the 13.8 to both sides. And when I do that, lo and behold, I end up with the answer that we already had figured out before we had even started this process. That's why I definitely recommend, especially with these types of equations or word problems, right? Use your noggin, right? You just think about it through. Don't get overwhelmed by the fact that I'm going to have you write an equation as to what that represents as an inequality. Let's look at the second word problem just to make sure we finish it off. A poll of likely voters shows that the incumbent will get 51% of the vote in an upcoming election. Based on the number of voters polled, the result for the poll could be off by as much as 3 percentage points. What does this mean for the incumbent in terms of how many votes or what percentage of votes they could get? So, right, if you've been paying attention to pollsters, especially with this whole election, right, they always tell you what their margin of error is. The pollsters, less like 4 years ago, were very much wrong, but yes, what can it be?
So would we write this in 0.51 or just 5.1?
You can just write it in 5.1.
Okay, then
Or either. I mean, it would be fine either way.
48
Yep.
is less than or equal to x, which is less than or equal to 54.
Perfect, right? I'm basically going to write this with the answer that it could be 3 less than what the expectation is or 3 more than the expectation. The equation that matches this, I have less than statements, is I write my absolute value bars and then x minus whatever the expectation is, which is 51, and then less than or equal to what the margin of difference is, 3.
Is there ever gonna be a word problem where instead of it being number less than or equal to x and less than or equal to number is always, so it's always gonna be less than?
It's always going to be less than.
Okay.
These word problems are extremely formulaic, which is why I figured 2 was probably enough for us. Since we have a less than statement, right, we write one compound inequality going from -3 to +3, and then I add 51 to all components, and lo and behold, I wind up with the answer that I had expected. Good job, yes. Okay, so what I'm going to do